This problem and all other Calc 135 problems can be found in Sarai Studies. Link is in the description box below. So we just got done finding absolute extrema given graphs, but what if we're not given a graph? What if we're given a function instead and we're told to find the absolute max and min? What do we do then? Well, let's go ahead and consider this graph over here of the function f of x. If we consider x is equal to b to be the location of an absolute maximum and x is equal to a to be the location of an absolute minimum, these points are not just maximum and minimum, they're also called critical points. So the concept is if we could find the critical points given a function, then consequently we'll be able to find the points at which there are maximums and minimums. Now, I say this with a disclaimer because not all critical points are maximum and minimas. So when we get to that process, we do have like a little checking process where we have to check and verify, but all minimas and maximas are critical points. So if I'm telling you that x is equal to a and x is equal to b, these are absolute max and absolute min points, and they're also critical points, then let's analyze the behavior at these points to see if we can come up with some conditions that make up critical points that are absolute max and min points as well. Let's take a look at this point over here, absolute maximum. So what's happening over here? The first thing I notice is that in order for there to be a maximum in the first place, you have to go up and then you have to go down. But what does that translate to? Well, if the function is going up, what does that mean for the slope? Well, if the function is going up, this goes back to your algebra class, what is the slope of this line right here? From left to right, it's going up, so the slope is positive. So same thing over here. From left to right, the graph is going up, so what's the slope of the graph to the left of b? The slope is positive. So the first condition, the slope of all of the x values to the left of b have to be greater than 0. They have to be positive. But then consequently, in order to have a maximum, it can't just stay increasing, it has to come down. And so therefore, the slope of all of the x values to the right of b have to be less than 0. Why? Because it's coming down. Again, algebra class from high school. What is the slope of this line? It's going from left to right, it's going down. So it's a negative slope. So therefore, the slope to all of these values over here, they have to be less than 0 because the graph is coming down. But this is if the critical point is really a maximum. But what happens with the minimum? Well, the opposite situation. To have a minimum, you need to go down and then up, down and then up. What we're really saying is that to the left of a, the slope of the function have to be less than 0. But then what's happening to the right of a? The function is going up. What does that mean for the slope of the function at these points? That the slope is positive. So therefore, to the right of a, the slope of all the x values have to be greater than 0. That's the or, because a critical point could be a maximum or a minimum. Now let's go back to the maxima. In order to go up and then down, which is a requirement for a maxima, it has to go through 0. Because remember, this is how we count. We count 3, 2, 1, negative 1. Is that how we count? No. It's 3, 2, 1, 0, negative 1. So we go from positives to negatives, but we have to go through 0. So same thing, if we have a maxima, we go up for a slope, we have to go through 0 and then go down. So that is why if we go ahead and draw a line that's tangent to that point, we already know what that is. That's the slope. It is m is equal to 0. So what does that mean? It means that in order for there to be a critical point at x is equal to b, f prime of b, the slope of b, has to be equal to 0. And this is true for minima too. If we need to go down and then up for a minima, we still need to go through the slope being 0. So this is true for both maxima and minima. So f prime of b has to be equal to 0, or f prime of b can simply just not exist. So this is true because you have to consider a situation like this. If we have this graph over here, and let's consider this to be point b, wouldn't you say that this is a maxima because it's going up and then it's going down, and so this condition is good? But the problem is that f prime of b doesn't exist. Why? Because we discussed in previous chapters that this point over here isn't differentiable. Why? Because there's a sharp corner. What does that mean? You can't find the slope. The slope does not exist. And so just because the slope is not equal to 0 doesn't mean that it's not a maximum. We can literally see it's a maximum. Like it literally is a maximum. That's why we add this condition over here, because there are situations where there could be a maximum, but the slope is not 0 and instead it does not exist. And same thing for a minima. This could be a minimum. Again, it's not differentiable. M cannot be 0 here. That doesn't change the fact that it's a minimum. It's going down and then it's going up, so it's satisfying this condition over here. The only thing is that f prime of b just simply does not exist because you can't differentiate. You can't find the slope. It doesn't exist because of this sharp corner. All right, and the last condition, which is very obvious and very simple, is just that f of b has to exist. And if we're working with f of a, then f of a has to exist, right? But we're just focusing on b for the rest of these examples. That's it. So now I'm going to show you a little acronym that I kind of sum up all of this with. So anytime you hear the word critical point, think of CEO and then add a D, because I want you to remember that in the next few lessons, critical points are going to be your CEO. They're going to be your boss. They're going to be bossing you around. You're going to need them all the time, anywhere, and for most of the problems that you're going to be working on. So C stands for critical points. So let's say we think we have a critical point, X is equal to B. So in order for this to be a critical point, we have to verify the following conditions. So E stands for the fact that f of B has to exist. That's this condition here. Done. O is actually a 0. Stands for the fact that f prime of B has to be equal to 0. Done. Or just simply not exist. Done. So see, these are all of the conditions to check for a critical point. And then, you know when I said in the beginning that we have to check because not all critical points are maxima and minima? Well, that's where this comes in. This is the justification part, that if you don't justify your answer on the exams, you actually lose points. Just because a point satisfies these 3 conditions, it does mean that that point is a critical point, but it doesn't necessarily mean it's a maxima or a minima. You literally have to check if you think that point is a maxima, that the slope to the left of B is going up and then going down, because that proves that it's a maximum. So that's where the justification part comes in. So anytime you're trying to find critical points, think of CEO and then add a D at the end. And if you want to check that that critical point is an absolute maxima or minima, then you have to justify your answer by actually checking the slopes. And I'll show you how to formally justify your answer when we get to a problem. But first, I have to explain to you what the extreme value theorem is, EVT. And I'll do that in the next video.